In this module, we're going to talk about creating layers. In particular, we'll take a look at how to go about creating a vector layer for a vector data set. We'll also talk about how to create an image layer for imagery data and kind of discuss the processing that goes on in the back end during the image layer creation process. And towards the end of this module, we'll talk about what a mosaic is, why do we need one, and how to go about creating one. Now, after data is uploaded, whether it's vector or imagery, the next step is to add them to a layer. When you create a vector layer for a vector data set, you get a variety of options to control the look and feel and what part of the data set you want to display on the map. For a given vector data set, which is nothing but a collection of features, based on some of the attributes, you will know where they will appear on the map, but you would also like to control how they appear. For example, if it's point data, you want to be able to display them using marker icons. If it's polygon data, you want to be able to control the color information, for example. So a vector layer allows you to do all these things. On the other hand, in an imagery layer, there's nothing much for the editor to do except to bundle one or more imagery assets into an image layer and process it. Now, there's a lot of things that happen at the back end as you process an image layer. As these images are meant to be displayed as an overlay on top of the base map tiles, we do in the back end things like ensuring correct positioning, alignment, feathering of the edges, and so on and so forth. This could be a time-consuming process, so the image layer processing is one of the longest phases. Also, one of the other things that is different between a vector and an image layer is the number of assets you can include. For a vector layer, you can only add at most one data set, whereas for an image layer, you can have one image asset, multiple image assets, or you may also, based on this diagram here, choose to bundle imagery data sets into a mosaic before adding them to an image layer. And towards the end of this module, we'll talk about why sometimes it makes more sense to bundle the image assets into a mosaic to be processed as a single unit, and then add them to an imagery layer instead of directly adding them to an image layer. Now let's talk about vector layers. When you create a vector layer and add a vector data set to it, you can use the style editor from within the vector layer to create display rules to be applied onto the features in that vector data set. A display rule controls what the map is going to look like at a particular zoom level or a range of zoom levels. The minimum being 5, maximum being 24. To be more specific, each display rule controls two things: what features are to be displayed and how they will be displayed. What features to be displayed is done with the help of filters, and you can imagine filters to be something close to what a where clause of a SQL statement is. An example would be A equals 100, where A could be an attribute of the data set in question. As for how to display, this will depend on the geometry of the data set in question. If it was point data, we have a predefined list of icons to choose from. If it was polygon, then we have a bunch of other options, which we'll take a look at in just a bit. Coming back to filters, so each filter will have the format that looks something like this. Starts with an attribute, followed by an operator, and finally a value. An example is here: population greater than or equal to 10,000. So what I'm trying to say is, if for a feature, its population attribute has a value that's equal to 10,000 or above, it will match the condition of this filter, and so it will get displayed when this display rule is applied. Any feature whose population attribute does not match this condition will be ignored in this display rule, and so the effect of this is it will not get displayed on the map. Another example is, let's say you have a collection of features that describe city locations, and one of the attributes is name. So I could create a filter that says name starts with San. So for North California, for example, this would match city names like San Francisco, San Mateo, San Bruno, and so on and so forth. Also take note that when it comes to using strings and quotes, The filters are case sensitive. So if I use capital SAN, it will only match values that have capital S followed by AN in lowercase. Anything that starts with a lowercase s will not be considered a match, and so those features will not be displayed on top of the map. You're also allowed to have more than one filter in a display rule. How that is going to work is okay, so trying this part again. You're also allowed to have more than one filter within a display rule, and the way they're going to be applied is using the AND clause. For example, if I had these two filters as part of the same display rule, what I'm trying to say is I only will want to see features whose population attribute is greater than 10,000 and the name starts with SAN. So these two conditions must be met for that feature to appear on the map, else it will not appear on the map. As for the operators, here's a list of operators that we support as of now. The first three would make more sense for strings, and the rest could be applied to almost all data types. As for how to display the features will depend on the kind of geometry in question. So if it was point data, then you have a predefined list of icons to choose from, whereas if it was polygon data, for example, you'll have options like fill color, border width, and so on and so forth. So the UI will kind of adjust according to the geometry of the data set in question. Whatever it is, you'll be able to make changes, and you'll be able to see that in the preview. And so let's take a look at that over at the console. I'm going to use an example of a layer that I've created. So when I click on that layer, it brings me to the layer details page, and from within that page, I can use the menu on the left-hand side to click on Edit Layer Style. This will launch the style editor. And so what you see is the display rules that are listed on the left-hand side, and on the right-hand side, I can see a preview of what the application of display rules, of these display rules, will look like. Right, you could also have multiple display rules, and the way it's applied is exactly in the same order like how you see it. So we will always test features against the first rule, and only those features that do not match rule number 1 will be tested against rule number 2, and so on and so forth. So you want to make sure that you always start with the most restrictive rule, making your way to the least restrictive rule. So display rule number 1, as we can see, is applicable for zoom levels 5 to 10, and the filter here that I've created for this rule says I only want to see features whose place attribute is equal to locality. I'm guessing for this data set, it may have as features a list of locations, and one of the attributes of the features is place, which describes what kind of location it is. It could be locality, suburb, cities, but for zoom levels 5 to 10, for some reason, if I'm only interested in looking at localities, I can place a filter that looks something like this. And so as long as I'm within zoom levels 5 to 10, I will only see this particular icon that I've chosen, or I'm able to, let's change this to this red colored box. Any changes that I make on the display rules will activate this apply button. I will need to click on this apply button to make the changes effective. In other words, I'm processing the layer. Takes a few seconds, and once the layer is processed, you can see the preview of the changes directly in this preview box. And as long as I'm within zoom level 5 to 10, I will only see features that match this condition, this particular filter, and it's displayed according to the icon that I've selected right here. Now, if I zoom in further, notice how the display changes. What happens is when I zoomed in further, I went into higher zoom levels beyond what is described for display rule number 1, and so this display rule kicks in. And since there is no filter applied to this display rule, all the other features that did not match display rule number 1 will be displayed at these particular zoom levels. Also, since I've chosen a different icon to represent my point features, what gets displayed on the map is according to what's been set over here. To add any additional rules, I can simply click on Add Rule button right here. If for some reason I want to delete any of the existing rules, I can click on this icon over here and that particular display rule gets deleted. If you make changes, although the Apply button reprocesses the layer, it does not republish the layer, which is a necessary step for the layer to be usable in a map. So I could either select this checkbox so that it publishes automatically on exit, or I can exit first and then click on the Publish button later. So I'm going to just leave this box as checked so that the layer gets republished the moment I exit. And to check the status, I could either click this refresh button or just wait for a while. And now it says the layer has been published. And so what we saw was creation of display rules to help us control what features do we want to display at particular zoom levels and how we want them to appear. Also, we noticed that we could create more than one display rule, but the ordering of the display rule is very important. Again, you always want to start off with the most specific display rule, working your way to the least specific display rule. Another thing we can do from within the style editor is manage the info window contents. And the info window supports a restrictive set of HTML tags. Some of them are listed here on this slide, but feel free to take a look at the Help Center document to see the complete list of HTML tags that we support within the info window. And I'm going to show you how to get to that in the console. I'm going to go back to the layer. I'm going to launch the style editor. And within the style editor, if I click on this link called Info Windows, it brings me to the settings page where I can control what gets displayed within the info window. Now I can see that by default, all the attributes for this particular data set has been included in this info window, which is something I may or may not want. So I could remove all of them, and with the help of this drop down menu, I can choose one or more particular attributes that I want to see get displayed within the info window. Let's choose name and place. And since I've made changes, again I have to click on the Apply button to reprocess the layer. And once reprocessing is done, I'm going to go ahead and click on one of the features to show you the contents of the info window. And this is exactly what we expected, since we included only the name and place attributes in the info window. I see exactly that within the info window when it gets displayed. Also, one thing to take note of is that after you reprocess or apply the changes you've made from within your style editor, you will still need to republish your new layer. You could do this on exit, like how we saw in the demo a few slides back, or you could choose to exit without republishing and publish it at a later point in time. In that case, you will need to go back to the layer details page by clicking on the layer name, and you would see something like what's shown in the screenshot. You would have the option of publishing the new layer. Now that we've seen what a vector layer is all about, let's talk about image layers. Like I mentioned, image layer is a whole different ballgame altogether. There's no styling or filters or info window to play around with. But when you upload imagery data, the intention is to have these images correctly positioned and aligned on top of the base map tiles. We also want to make sure that each of these images blends in very well against the background, which in this case again is the base map tiles. And so part of the processing that gets kicked off during the layer creation process for an image layer sparks off a rather long and complex processing job which does exactly all these things. At the end of this process, we get a consistent visual experience, and it will appear as if all the images were part of the same overlay imagery layer to begin with. Of course, since there's a lot more complex operations to be done, the time taken to process an image layer is a lot longer compared to that to process a vector layer. Now, part of this image layer creation process includes, among other things, the feathering along the edges of each individual image. What this really means is, you can imagine as if the images are blurred along the edges so that we are able to blend it well or merge it well against the background, or in other words, the base map tiles. Now, this is okay in some cases if the images are not contiguous or they are not meant to be next to each other. However, consider this. You have imagery for a city, and chances are they will not fit within a single image. And so it could be a 3x3 matrix, let's say. So you would have uploaded 9 individual images that are supposed to be placed next to each other. Now, if you add all these individual images to an image layer, as part of the processing, what's going to happen is the feathering is going to blur the edges of each individual image. And as a side effect of this, and as a result of this, what's going to happen is you're going to lose some crucial information along the edges of each individual image. And so what's going to happen is a side effect that looks something like this. Along the edges, you will start seeing white lines. So at first glance, it may not appear that big a deal, but if you zoom in further, these white lines start becoming more obvious and kind of distort the visual experience that was intended for the user. This is a side effect of the feathering that happens as part of the processing, and so we want to avoid that, especially for cases where the images were part of a bigger picture and they are meant to be stitched together, and we don't want the feathering to happen until these images are placed together as one single unit and treated as one single unit. And so the solution to that is a mosaic. What a mosaic really is that it's a container that allows these individual images that were at some point in time part of a bigger picture to be treated as one single image. And so what you're going to do is, instead of placing these individual images directly into an image layer, you will create a mosaic and place these images into a mosaic. Putting these images into a mosaic places them together next to each other, but does not run the feathering process. In other words, there is no blurring along the edges of each of these images, and so as a result, we get a better output compared to what we saw earlier. In this case, we do not see the white lines anymore. And so as long as you have images that were part of a bigger picture and they were meant to appear alongside next to each other, and you do not want any of the information along the edges to be lost as a result of the feathering process, you want to make sure that they are included as part of a mosaic before adding them into an image layer. Mosaics are meant for contiguous images, but if you prefer to put images that are not related to each other into a mosaic and then add them to an image layer, you may choose to do so, although that doesn't really change the ultimate output. Nonetheless, if you want to do so, you can. Also, since the idea of creating a mosaic is to bundle images that were part of a bigger picture, so the assumption is that they would have the same number of bands, the same projection, the same resolution, north-south orientation. And so as long as two individual images that are meant to be added into a mosaic do not match in any of these properties, the operation will fail. In other words, you are not able to bundle two images if they do not match in any of these properties. So you want to make sure that whenever you create a mosaic, each of the individual constituent images that are to be part of the mosaic match in all these properties with each other. And so adding them to a mosaic will give you a much better output compared to adding them to an image layer directly. Once you've added these individual images to a mosaic, they are treated as one single image, which is what you wanted to begin with. Now you are ready to add this mosaic to an image layer and process the image layer. What's going to happen is the feathering, among other things, is still going to take place, but now the feathering process is going to blur the edges of the overall big picture, of the overall image that's made up of all the individual images after you've stitched them together without applying the feathering then, which is okay because this would have happened anyways. One final thing about mosaics is that when you add images to a mosaic, they are hidden from the data sources section because now they are part of a mosaic and they do not appear as individual images. However, when you at some point in time in the future delete this mosaic, what happens is only the container information gets deleted and all the constituent images are released back into the data sources section. And so as long as an image is part of a mosaic data set, you're able to look or list these individual images by clicking on the mosaic data set and looking at the constituent images through the mosaic details page. Another way to access hidden images would be to use the search tool and checking the hidden content checkbox. So let's show you that on the console right here. I'm going to go into data sources, and although I don't have a mosaic data set in this account, I can just launch the search tool by clicking on this icon, and I can check this checkbox right here that says include hidden content. So what this is going to do is it's going to search for data sources that has the word SF. Let's say I'm looking for imagery and vector data set with the word SF in it, and this search is also going to include hidden content. So even if there were imagery files that had the word SF in it and they were part of a mosaic, they will still be listed in my search results. When you create a mosaic and add images to it, you will need to process this mosaic. The processing basically does the stitching of the individual images together to produce one single image as the output. Even if you have not processed a mosaic, you may still be able to add that mosaic data set to an image layer. However, you will not be able to further process that image layer until and unless the mosaic has been processed. So it's always a good idea to make sure that the mosaic that you intend to add to an image layer is already processed before you add it to any imagery layer. Some numbers for creation of mosaic. So the maximum number of images that you can include in a mosaic data set is 200,000, and there is also a total maximum file size, or rather mosaic data set size, which is 500 GB uncompressed. So what this means is, as you add images to a mosaic data set, the sum total of all these images cannot exceed 500 GB. If you wanted to include images that grow beyond this size, you will need to bundle them in a whole different mosaic data set altogether.